the friction will act like this. Okay, let's talk about the normal reaction. Now as I apply force, the body what happen, as I keep on increase force at one particular value of F, what happen, it starts toppling. About what point it will topple? I think if you have any rectangular box or something, no, if you start pulling, tell me like this particular box, will it rotate about? There are 4 points are there. Will it rotate about center of mass? Will it rotate about P1? Will it rotate? Will it starts rotating about P2? As you keep on increase this force, and one particular value of F, what happen? It starts toppling about P2, no? It starts rotating. So, sir, what do you mean by it starts rotating? It starts rotating. So initially what happened, the body will be like this. As you keep on increase force, this particular object, oh, the toppling will be, yeah, it will be like this. It starts toppling like this at one particular point. It starts toppling. Agree? This is a very general. Sir, why do it rotate like this only? You must have the basic common sense. So why don't it rotate like this anti-clockwise? About P1, why don't it rotate? No, it will tip about point P2, not about P1. When you apply force here according to the diagram, it will tip about point P2. Okay, now what is the maximum force for which no toppling occurs, or what is the minimum force for which toppling will take place? There are 2 ways I can define. So find the maximum value of F. Find the maximum value of F for which the block will not topple, or minimum value of F for which block topples. I think both are same, no? Okay, what we have to do again here? Okay, let's do one thing. We are very good in laws of motion chapter. I'll show the end acting like this. Let's calculate the, is I'm right? Yes. So let's go for torque about point C. Let's calculate torque about point C, about axis passing through center of mass perpendicular to plane. This should be equal to torque due to applied force, F into B by 2 clockwise. Torque due to friction, F into B by 2 clockwise. So net torque, how it is? It is in fact clockwise, no? So the moment you apply force, what happen? Is it any? Okay, shall I continue? Are you able to hear? Yes, yeah.
Yes, sir.
No, let me continue. Now, the moment I apply force, will it starts tipping, or will it start toppling about point P2? No. I'll keep on increase force at one particular value of force. It starts rotating about point, or it starts toppling about point P2. But the equation, what it says, the moment you apply force, it will start rotating. But practically, it will not happen. No. Therefore, what is the problem now? The normal reaction, still the body, the net torque will be 0. So therefore the normal reaction will not act in fact here. In fact, it will be shifting. So in the books, what happened? They have shown it here. I'll measure X from this particular thing. I'll keep on increase applied force. What will happen to normal contact? The normal contact also will shift. This normal contact also, I think we can't do this. Yeah, leave it. So what happened to normal contact? Earlier it was acting. As I keep on increase applied force, the normal contact will start shifting. Then, so you see that one. Now, can I justify why the block is at rest? Why block is at rest? So the normal contact will act here. So what is the torque here? Will be like this. So net torque is 0. So now let me do one thing. Let me come into this one. Is applied force. The applied force such that it will be less than limiting friction. So as I keep on increase applied force, this static friction also will increase. Both F, capital F and small f increases. B by 2 are constant. And N is equal to mg. We know it. I think there's no doubt in that. What I should write? N is a constant. Tell me, like, as I increase F, the static friction will increase. B by 2 constant, N equal to mg constant. So then what should increase? X should increase. So therefore, what happened to normal contact? It keeps on shifts. I think there's some upper limit for X. No, what is the upper limit? A by 2. X cannot be greater than A by 2. No, sir, what's wrong in if you assume X equal to A by 2? Is it possible? I think if you prove this, you'll get a Nobel Prize. Huh? Is it possible for normal contact to act here? This should not happen, no? So what is the maximum permitted value of N? The maximum permitted value of N is what? Should be A by 2. You cannot show N here, somewhere acting here. At the most maximum, it can shift till here. Why do normal contact will shift? Already I explained. I covered background. Again, don't trouble me with sir, why normal contact will shift. And I'll not answer also. Already explained. Okay, now as I keep on increase applied force, friction will increase. The X will increase here. So I'll write the reason as F increases, X will increase. What is the maximum permitted value of X? A by 2. So let me take the diagram now. The weight mg, applied force, the friction, and there's a normal contact. So there's a point P2. Now, so now what happened? The block is about to topple. About to topple. About to topple means about what point it will topple? About P2 only. So the net torque, I'll shift it now. P2Z. This should be, it's about to topple. So this should be equal to how much? F into B by 2. Or say F into B. Perpendicular distance. This length is B, no? So this should be all the torque clockwise. Plus mg into A by 2. This will be anti-clockwise. And this is equal to 0. So this I'll call it as maximum. Why maximum? Because N has shifted this one. I keep on increase. This is the permitted value of F for which the block will topple. So now substituting this mg A by 2. So what is the value of F now? The maximum force is given by mg A by 2b. If the applied force less than this value, the block will not topple. If applied force is greater than this, it will topple. It will topple about what? About P2. So got this one. So what is the maximum permitted value of force? This one. So shall we put like this? F less than F max, the block will not topple. F greater than F max will topple about point P. Will topple about point P2. There's a basic background. So hereafter you should directly come for P2. Don't analyze here. You know concept. So what is the conclusion now? F less than F max, block will not topple. F greater than F max, blocks will topple about P2. Okay, this about the toppling is what I brought it. Topple means it's going to tilt about point P2. After this, so there's a friction is also there. Now the applied force is such that there are two possibilities are there. I applied a force where block will not topple, will not slide. I applied a force such that the block will topple before sliding. Or it can happen that the applied force such that the block will slide before toppling, or the block will topple before sliding. Then any relation between the mu and the dimensions of the body. Any relationship can we bring? What is the maximum force for the block to topple? This one. What is the maximum force for the block to not to slide? mu mg, limiting friction. So can we bring any mathematical relationship between them? So I'll proceed to the next concept. This is about the concept overall. This is very important. This is the fundamental one. This one. So let's come for conditions for sliding before toppling, toppling before sliding. What is the maximum force for the block to topple? So this is the diagram. So this is a friction will act. So these are dimensions we took like this. This is a E. What is the maximum force for toppling? mga by 2b. What is the maximum force for? I'll call this is F1. I'll call this F2. Mu s mg. When the applied force greater than F2, the block will slide. When the applied force is greater than F1, the block will topple. Now, what should be the conditions for the block should topple before sliding? Means block should topple before sliding. Means I applied a force. That force should be such that what happen first it should topple before sliding. So definitely what happen F1 should be greater than F2. No? F1 should be less than F2. The applied force should be such that it should be less than F2 because block should topple before sliding. What should first occur? The toppling should first occur. So the applied force should be greater than F1, should be less than F2. So what is the condition? The block should topple, no? Or block applied force should be mga by 2. At the same time, this force should be less than the friction force. Mu s mg will take it. How to bring this between mu s and a to b, that one? So definitely for what is the condition? Block should topple before sliding. Which force will be greater? The applied force should be such that less than limiting friction, but should be greater than the toppling force. I think that's what idea, no? So how to get relation between mu s and a to b? I think it's quite very, straight away what happen, we have to take help of. Any concept, shall we go for it, or it's a very general, just by looking at we can tell? And this should be F should be equal to mg a by 2, no? So definitely this force is what happen? Less than mu s mg. So mu s mg greater than block topples before sliding. So therefore this mu s should be greater than or equal to a by 2b. This is a method of solving the problem here. I think I'll take it out this. Yeah, it'll be better. Now similarly, block slides before toppling. So then what should be the F? F should be greater than or equal to mu s mg. What is value of F? F should be equal to mg a by 2b. So now in this case what happened? A by 2b should be greater than mu s. I think it's one of the same, no? Or mu s less than. If mu s greater than a by 2b, the block will topple before sliding. If mu s less than a by 2b, the block will slide before toppling. So if you apply force, whether block will slide or topple will determine the dimensions of the object and the coefficient of friction. That's what I'm trying to correlate. Just statistical information.